Hi, my name is Thomas Pesquet, and I'm an ESA astronaut on board the International Space Station. From here in space, our planet may seem far away, but the station I'm currently on is flying only 400 kilometers above the Earth's surface. I'm in the Columbus module, the European Science Laboratory, where we have 16 racks around me filled with experiments and equipment. In this unique environment, we explore principles of everything from material science to fluid physics and life science. But this research isn't just useful for space, it can also play a role in the lives of people on Earth. You may have noticed that my Alpha mission patch has 17 colored slots around the edge. Each of these represents one of the Sustainable Development Goals of the United Nations. The SDGs are a collection of global goals to achieve a better and more sustainable future by the end of this decade. Today, I want to show you how space research is relevant to 3 of these goals: good health and well-being, SDG 3, zero hunger and food security, SDG 2, and climate action, SDG 13. First, let's talk about health. Here in weightlessness, our bodies do not have to work as hard as they normally do on Earth. This can be fun, but it also means our bones and muscle become weaker. And while losing bone and muscle at an accelerated rate isn't great for astronauts, it is very useful for research. Recently, data was collected from a dozen astronauts on 6-month missions here on ISS, looking at changes in bone structure. This work helped pave the way to develop high-resolution scanners that analyze bone and joint disease in just 3 minutes. This non-invasive 3D imaging is essential to assess the microscopic architecture of bone and their strength, all while exposing the patient to very low levels of radiation. Here in the cubic facility, the molecular muscle experiment looks at very small worms that have a few key similarities to human muscle to investigate how muscle structure and genes are affected by spaceflight. By studying how and why our muscles change in space, we can learn how to counteract it in future astronauts and potentially help people on Earth who suffer from muscular disease. And now let's see how space research is helping to tackle SDG 2, zero hunger and food security. Here, in Biolab, right next to me, we've been studying a blue-green alga called Spirulina in an experiment called Astronaut B, or Bravo. Spirulina are photosynthetic, meaning they can recycle carbon dioxide into oxygen, and they are not only edible, but also very nutritious. The Melissa initiative and the researchers from the Belgian Nuclear Research Center have researched various aspects of the bacteria, such as how they absorb light, ingest nutrients, and more. And now, in collaboration with the nonprofit Entrepreneur for Entrepreneur, they are applying this knowledge to improve food quality and security around the Congo town of Bikoro. Here, the spirulina is grown in tubs of water and then dried and powdered. Only 10 grams sprinkled on food every day is enough to satisfy most dietary requirements and supplement the diet with much needed protein, vitamin A, and iron. Last, let's investigate how space research can help us understand Earth's climate. Behind me, over there, on the outside of the Columbus Laboratory, there's a small experiment called the Atmosphere-Space Interaction Monitor, ASIM. It's the ISS' very own climate observatory. Outfitted with highly sensitive optical cameras, ASIM looks for electric events in the Earth's upper atmosphere. These observations could hold cues to how lightning is initiated in clouds, can improve our understanding of the effect of thunderstorms on the Earth's atmosphere, and help build more accurate climate models. I hope you have enjoyed this video and learned how space research is used to improve the quality of life every day on our planet. Many greetings to all of you from space.